My name is Maddie Lamson and our group did whale harvesting. First, we're going to start off with a little background information. In the report of the International Whaling Commission in 1978, J.R. Beddington refers to the following model of the female half of sea whale population subjected to harvesting. So first, it gives us the starting equation. N sub t plus 1 is equal to 0.94 n sub t plus n sub t minus 8 times 0.06 plus 0.0567 times 1 minus n sub t minus 8 all over n star raised to the 2.39 power minus 0.94 ct. And this, we'll refer to this equation as equation 1. So first we're going to define some of the terms in the first equation. So n sub t plus 1, n sub t, and n sub t8 are the adult female whale population subjected to harvesting in years t plus 1, and t minus 8. Ct is the number of female whales harvested in year t. N star is the number of female whales that environment would support with no harvesting taking place. We're also going to note that the adult female whales are age at least 8 and no juveniles are subjected to harvesting. The number of female whales 8 years before T are the number that could make babies and now can reproduce. So this equation represents the number of 8-year-old females recruited into the population at year T, and this equation is the per adult whale new whale marketing rate is called the fecundity. We know fecundity increases when the population decreases, and the parameter 2.39 was chosen as a good fit by Beddington. So the first question is asking, so that if there is no harvest and both n sub t and sub t minus 8 are equal to n star, then n sub t plus 1 equals n star as well. So first we're going to erase these two bottom equations. So for the first problem, we're going to have Ct is equal to 0. And then we're also going to plug in n star, where we see n sub t plus and n sub t minus 8, and then we'll go from there. So we're going to have n sub t plus 1 is equal to 0.94 n star plus n star times 0.06 plus 0.0567 times 1 minus n star over n star raised to the 2.39 power minus 0.94 times 0. So when we're looking at the equation, we're going to see what we can combine and what we can simplify. So what we first see is right here, n star over n star is equal to 1. And 0.94 times 0 is 0. So we're going to rewrite n sub t plus 1 is equal to 0.94 n star plus n star times 0.06 plus 0.0567 times 1 minus 1 to the 2.39 power minus 0. So we're going to do what we just did. So we're going to analyze the equation and see what we can simplify. So we see that 1. 2.39 is equal to 1. So we're going to rewrite the equation. N sub t plus 1 is equal to 0.94 n star plus n star 0.06 plus 0.0567 is 1 minus 1. The equation n sub t plus 1 is equal to 0.94 times n star plus n star times 0.06 plus 0.0567 times 1 minus 1. So we're going to simplify that down a little farther. So now we will have n sub t plus 1 is equal to 0.94 n star plus n star times 0.06 plus 0.0567 times 0. So we know that 0.0567 times 0 is 0. So now we will have n sub t plus 1 is equal to 0.94 n star plus n star times 0.06. Because we're just leaving the 0.06 because 0.0567 times 0 is 0. And that will just leave us with the 0.06. Now we can rewrite it. N sub t plus 1 is equal to 0.94 n star plus n star 0.06. So now we can combine like terms, and 0.94 plus 0.06 is equal to 1. So we get n sub t plus 1 is equal to n star. And that is the end of question 1. In question 2, it says after scaling each population to a fraction of its carrying capacity, they gave us this new scaled equation, which is n sub t plus 1 is equal to 0.94 n sub t plus n sub t minus 8 times 0.06 plus 0.0567 times 1 minus n sub t8 to the 2.39 power minus 0.94 ct. And then we'll just refer to that as equation number 2. So in letter A, it says suppose n star is equal to 250,000 and a quota of 500 whales is harvested each year. These are both from the female population. Change CT above and in the original equation to reflect this. So what we're going to do here is we're going to plug 500 in for CT into equations 1 and 2. So we're just going to make a note, plug 500 into CT for equations number 1 and equation number 2. So first off, we're going to plug in 500 for equation 1. So it's going to look like n sub t plus 1 is equal to 0.94 n sub t plus n sub t minus 8 times 0.06 plus 0.0567 times 1 minus n sub t minus 8 all over n star raised to 2.39 power minus 0.94 Next, we're going to plug 500 in for equation 2. And that will look like n sub t plus 1 is equal to 0.94 n sub t plus n sub t minus 8 times 0.06 plus 0.0567 times 1 minus n sub t minus 8 to the 2.39 power minus 0.94 times 5. And that is the conclusion to part 2A.
Question number 2, part B, asks us, suppose 2% of the adult female whale population is harvested each year. Change C of t above and in the original equation to reflect this. So we will plug in 0.02 N2 for C to the t in equation number 1 and equation number 2. Equation number 1 comes out to be n of t plus 1 equals 0.94 nt plus n to the t minus 8 times 0.06 plus 0.0567 times 1 minus n to the t minus 8 divided by n asterisk to the power of 2.39. And then you multiply that times negative 0.94 times 0.02 times n to t. And then equation number 2 gives us nt plus 1 equals 0.94 n to the t plus n to the t minus 8 times 0.06 plus 0.0567 times 1 minus n to the t minus 8 to the power of 2.39. Then you multiply that times negative 0.94 times 0.02 times n to the t. And then part C asks us, what is the meaning of the perimeter 0.94 at the 2 places it is used in the new scale equation? And the perimeter is restricting the population that is at least 8 years old. Thank you.
So problem 3 asks us to develop a quantity as a function of n sub t minus 8. You may use the rescale equation 0.06 plus 0.0567 times 1 minus n sub t minus 8 to the power of 2.39. So we graphed the equation 0.06 plus 0.0567 times 1 minus x to the 2.39 in place of this on Desmos, which is where we get this graph minus the red line for the tangent line. So A is consider the rescaled new equation, and it tells us what we're going to let n sub t equal, which is n sub t plus 1, which equals n sub t minus 8, which equals ne. And so we're letting that be a constant population, which is the same over many years, and ct equals c, which is also constant. So it asks us to draw the graph of c as a function of ne. So we get the function ne equals 0.94e plus ne times 0.06 plus 0.0567 times 1 minus ne to the power of 2.39 minus the 0.94c from this problem, and then so we're going to solve for this c. So we get the same, we get ne minus 0.94 ne minus ne times this equation equals negative 0.94c. So we're going to divide by that negative 0.94 on both sides, which gives us c, which equals ne minus 0.94 ne minus ne times 0.06 plus 0.0567 times 1 minus ne to the 2.39 divided by 0.94. So then c, we're describing c as a function of ne. So c of ne equals ne minus 0.94 ne minus ne times 0.06 plus 0.0567 times negative ne to the 2.39 power divided by 0.94. So, and then b, that's a, that's our answer for a, which is we're finding c, and then b is where we're finding a point on the graph of c of ne, and what's the tangent to the graph is horizontal. So we look above to the graph, we write our tangent line, and then this area right here, which is circled, is where the tangent line is horizontal to our graph.
Okay, and then part C of question 3 asks us to compute the derivative of c of ne and to find the value of ne for which n equals 0, or the derivative is 0. So we just did that here. So we plugged in c, and then we took the derivative of c. So we got c prime of ne equals 0.0567 over 0.94 minus 0.192213x to the 2.39 over 0.94. And then we just set that equal to 0 and solve for NE, or which is x in this case. So then it was just 0.0567 over 0.94 minus 0.192213x over 0.94, and the x is to the 2.39 power, and set that equal to 0. And then we just plugged it into the calculator and solved it, and we got NE equals 0.615747755.
Our references are the book Calculus for Life Sciences, A Modeling Approach, Volume 1. The tutors at the Edge Tutoring Center, Creighton University, and then we use Desmos to do the graphing. Thank you.